Hey everybody, today we're going to be talking about laws of exponents. Some of these exponents properties you have already talked about, but we're going to go ahead and refresh on these, that way we remember all of them and we have a fresh start in case we have forgotten. We also will introduce a few new ones as well. Alright, so any number to the first power will be itself. So x to the first is simply x. So if I were to type in my calculator 5 to the first, my calculator is going to simply tell me the answer is 5. I could also say 104 to the first power will still be 104. Alright, now anytime I have the same base, so you'll notice here that the bottom number, the big number, is x. It's the same base. And I have two different exponents. When I multiply those, I would end up adding the exponents a and b. So let's have an example. Let's say 9 to the 7th times 9 to the 2nd. Because I have the same base of 9, I simply rewrite 9. And I would add the exponent 7 plus 2 is 9. Now if I were to look at the same problem over here, x to the a divided by x to the b, it's the same problem, same base. This time instead of multiplying, I'm dividing. So what you would do is you would subtract the exponents. So if I were to take a look at the same problem, 9 to the 7 over 9 to the 2nd, this time instead of adding the exponents, I would subtract them. 7 minus 2 is 5. So that would be 9 to the 5th power. Now here I have a base, x, that is raised to a power of a. I take this whole thing and then raise it to another power of b. You'll notice that this problem is different than the second problem because it has one base of x. So when I take a power to a power, if I raise x to the a to the b power, I would multiply a times b. So let's say that we're going to continue to use the same problem, 9 to the 7th, but this time we will square it. So 9 to the 7th, then squared, what you're going to do is you're going to multiply these two exponents. So you get 9 to the 7 times 2, which is 14th power. Alright, so now if I were to have multiple bases inside the parentheses, what I have to end up doing is I have to distribute the c to both the a exponent and the b exponent. Now I cannot combine my x and y bases because they're not the same base. That would be like if I had 3 and 5, they're not the same number, so I cannot combine them the way I did in problem number 2. So this you would still multiply as you did in the previous problem, but multiply to both the a and the b. Alright, so let's come up with a completely different problem using variables. Let's say m to the 4th times L, and then let's put parentheses around that. Oops, excuse me. And let's say that we want to raise this to the power of, how about 3? Alright, so what I would have to do is this power of 3 needs to be distributed to both the m to the 4th and to the L. Now, here's what's important about this. There is no exponent on the L. If we go back to problem number 1, however, we will see that any time I have a number, it's really that number to the first power. So over this L on top of the exponent is really an understood 1. So now what I need to do is I need to distribute this 3 to both the m to the 4th and the L to the 1. So m to the 4th to the 3rd power, you would multiply the 4 and the 3 to get 12. And by distributing the 3rd power to L to the 1st, it's L to the 1 times 3 or L to the 3rd. Alright, now looking at this next problem here, we can see that it's x to the a over y to the b. Now, because these are different bases, I cannot simplify it in the way that I did at problem number 3. So I have to leave this alone. However, I see a c on the outside, and I can distribute the c into both the a and the b in the same way that I did the problem above. So let's try that using the same problem that we did. Let's do m to the 4th over L in parentheses to the 3rd power. Oops, my 3 got a little away from me. So what I will do here is distribute the 3rd power to the 4 here, and the third power to L to the 1. So what I would have is m to the 12 over L to the 3. So notice it's the same thing that happened in the previous problem, except this time we left the division problem alone, whereas above we had a multiplication problem that we left alone. Now occasionally you're going to get a negative exponent. Let's say, for example, we have a division problem up here. Let's say it's, let's do a variable. Let's say n to the 4th over n to the 8th. Well, let's do 10. How about that? Go big. Alright, so because of this, I know that I need to subtract these two. It would be n to the 4th divided by n to the 10th is going to be n to the 4 minus 10, because you always do top minus bottom. That is going to end up leaving me with an n to the negative 6. We are not allowed to have negative exponents anymore. So what's going to end up happening is the negative actually tells me to change the location. Currently, this n is in the numerator of a fraction. It's n over 1. It's at the top. So the negative will tell you to move to the bottom of the fraction. So let's say, for example, my n to the negative 6 here, let's use that. N to the negative 6 is actually 1 over n to the 6th. Once I move it down to the bottom of the fraction, the exponent becomes positive, or happy if you will. Now let's imagine a problem like this. What if I had 1 over x to the negative 2? The negative exponent in the bottom tells me it's not happy where it's at, so what I need to do is actually move this from the bottom to the top. So when I move it to the top, it becomes a positive x squared. Now, the last thing you need to know is that any number raised to the 0 power is going to be 1. So try it. Tie in your calculator some really big, obnoxious number and see what you get. So the number that I chose was 536,873 to the 0 power, and my calculator says 1. So no matter what, if it's raised to the 0 power, you are going to get 1. Alright, so let's go ahead and work some example problems. The best way to understand properties of exponents is by practicing. We're going to do it over and over and over again. Now, in between this 2 and the m squared, this is 2 times m squared times 2 times m cubed. So what I can actually do is I can rewrite it so it looks like this. Notice I did not change the location of anything. Now, what I want you to do here is I want you to reorder things. Notice that the 2 and the 2 are what we call like terms. They are both constants. So I'm going to rearrange them so that they appear first, 2 times 2. And I also have m squared times m to the 3rd. Now, I am allowed to do this by the commutative property of multiplication. I can move things around. 4 times 2 times 5 is the same as 5 times 4 times 2. Just because I move the location does not change it at all. So what I need to do is I need to combine my like terms. I need to combine my 2's, and I need to combine my m's, so my constants and my variables. Now 2 times 2 is 4. And m squared times m to the 3rd. Go back to looking at your properties of exponents, that graphic organizer we just did. When I have two bases that are the same, both m's, and they are raised to a power each, and I'm multiplying them, all I do is add the exponent. So 2 plus 3 is 5. Alright, so that will be your final answer. Alright, let's go ahead and work on the next problem. Again, I want you to rearrange. I want you to put your constants out front. So we have m to the 4th times 2 times m to the negative 3. Now, some of you may have the gut instinct of going ahead and moving this to the bottom of a fraction. You are welcome to do so. There are multiple ways to do it. However, I notice that when I handle the m's, I'm going to end up with a positive exponent. So I'm not going to move it to a fraction just yet. So by moving a constant to the front and grouping my variables together, I have 2. There's nothing else with it, so I just simply bring down the 2. Now by combining m to the 4th and m to the negative 3rd, this is a multiplication problem where the bases are the same. So I add the exponents. 4 plus negative 3 is a positive 1. So you can write it as 2m to the first power, or I would also accept it as 2 to the m, because the very first thing in our property of exponent is anything to the first power is itself. Alright, so let's go ahead and try this problem. What I'd like for you to do is pause, give it a shot. Remember to reorder your constants first, then your variables, and then combine your like terms. So go ahead and pause the video and try it on your own. Alright, hopefully you are unpausing the video because you are done and want to see if you did it correctly. So this is 4 times r to the negative 3 times 2 times r squared. By reordering, I put my constants first, 4 times 2, then my exponent, or my variables are r to the negative 3 times r squared. Alright, so let's begin by combining like terms. 4 times 2 is 8. This problem is the multiplication of like bases, so I would add the exponents. This becomes r to the negative 1. Now, here's where I need you to understand something, okay? R to the negative 1, this negative 1 only applies to the r. The 8 has a positive 1 exponent. Because the 8 has a positive 1 exponent, it stays on the top of the fraction, while the r is the only one that moves. So the answer to this is 8 over r. Okay? Now, here's a side note to help you understand. If you got 1 over 8r, I want you to pay attention very closely. If this was the answer you got, it is incorrect, and let me show you why. Okay, if I were to have parentheses 8r to the negative 1, this negative 1 applies to everything inside of the parentheses, and this becomes 1 over 8r. In the problem that I had, it was 8r to the negative 1, where the negative 1 only applied to the r. So it's 8 over r. Notice the difference in the way that these two problems are written. Parentheses means everything inside gets the exponent. No parentheses means just what I'm next to. This is the exponent that it belongs to. Okay, this is very crucial. Alright, so we're skipping around a little bit. Let's take a look at number 11. Number 11 has a parentheses to the 0 power. Notice that this 0 power, remember, if anything to the 0 power is 1. So that means that everything in this parentheses is actually just 1. Now let's say I give you an obnoxious problem like this. Z to the negative 3, x to the 4th, y to the negative 3rd, all of this to the 0 power, and you're like, okay, this is a really long problem. Guess what? Remember that parentheses means that this exponent belongs to everything inside of it. So everything in here is to the 0 power, and anything at all to the 0 power is 1. So when you have a problem like this, I want you to check and see first, do I have a 0 exponent? Alright, now for this one I have a parentheses with an exponent on the outside. And now remember that this negative 4 exponent must apply to everything inside of it. Notice that this 2 does not have an exponent, however we can put a 1 there. We know that we need to multiply the negative 4 to the 1 and to the 2. So this becomes 2, and then 1 times negative 4 is negative 4. And x to the second to the negative 4th, I multiply those, and it becomes to the negative 8. Now notice that both the 2 and the x have negative exponents. That means they're going to both have to move to the bottom. And because of that, we'll put a 1 on top to hold the place. Now I can simplify this a step further. 2 to the 4th doesn't have any variables in it, so when I type it in my calculator, it is 16x to the 8th. So 1 over 16x to the 8th. Now for problem number 21, I want you to reorder this in the same way we did multiplication. Okay, this is r squared and r cubed, and then there's a 2 over here on the bottom. Well, there's an understood 1 right here. 1 times r squared is just r squared. So 1/2 will stay 1/2, and r squared over r cubed, you subtract them, so you would get r to the negative 1. Because the negative exponent, it's going to move down to the bottom and become r to the positive 1. Okay? So just be careful with that. Alright, so for the rest of the problems, we will do them as practice. I will see you later.